All right, this is problem 7.1.9, and they're asking us to determine whether the following is a function. And so they tell us that the domain is a set of triangles, the correspondence is the area of a triangle, and that the range is a set of numbers. So remember that when we're talking domain and range, there's always a correspondence between them. And so if you're looking at, some kind of a correspondence between a domain and a range, something is considered a function if you have it being able to pass essentially the vertical line test. If we're talking in terms of a graph, a vertical line test would mean that anytime you drop a vertical line down through the graph, that it hits only once. Okay, so that means that there's this situation where you only have a correspondence between this x and this y. A situation where like the vertical line test would fail would be something like this, like a circle. So with a circle, you can see because a vertical line dropped down through it hits twice, it's actually not a function, and that's because we have this one x right here corresponding to two different y values. Okay, so that's not a function. This is a function, and so when we look at this, they're not giving us a graph, they're not giving us numbers, but what they're asking us to do then is make this correlation and determine whether it's a function or not. So if you have a set of triangles and you're looking at the property of the triangles that you're looking at is the area, each triangle is only going to have one number for its area. And so if we try to make this correlation between the domain and the range, if the range is a set of numbers, this would be a function because each of these triangles will have an area that is a number, and it will just be one number, so it will look something like this. And this scenario of this one element here mapping onto this element here is going to give us a situation where we are talking about a function. So yes, this one, this relationship here would be considered to be a function. Okay. I also wanted to do problem 7.1.13 also in this video, and you have to pardon me, I have a bit of a cold. So what they're asking us here is they're giving us this function f of x equals x plus 17, and they're asking us to find each of these values right here. And so what we're going to be doing is plugging in these values for x and then just evaluating. So f of 0 would be 0 plus 17, and when we do the math, that would be 17. And f of negative 19, when we plug that in, so we're plugging negative 19 in for the x. So we have negative 19 plus 17, which is negative 2. And then plugging in negative 7, we're going to have negative 7 plus 17, which is positive 10. F of positive 19 is 19 plus 17, which is, excuse me, 36. Okay. All right, so f of d plus 17, what we're doing here is we're actually plugging in an expression, and because we're plugging in an expression, we're not actually going to get a number like we got in the rest of these. We're going to get an expression. So we're still plugging this d plus 17 in for the x, and so it's going to look like d plus 17 plus 17. So this plus 17 right here is this plus 17. Okay, so this is the bit that we've plugged in for x, and then we're still adding the 17 there. That's part of the function. And so if we go ahead and collect like terms here, then we have d plus 34, and this would actually be the solution to this particular portion of what they're asking for in this problem. And that's it on these problems.